Hello, assalamu alaikum.
Wa alaikum assalam.
Inshallah, Jum'ah Mubarak. Can you see my screen?
Yes.
That's good. So, inshallah, today we are going to have our last class, data mining, as the semester is coming to an end. This is week 12. So, according to our lesson plan, this will be our last session for the lecture, and then also for the live exercise. I think we had the last sessions this week. So, inshallah, next week we are going to begin our presentations during the lab sessions. So we have taken a lot of time actually discussing some different aspects of data mining, where we begin with the introduction of the concept of data mining and why data mining is important, especially in today's world. We are always working on data. So data, as there is always a saying, data is the oil of 21st century, which all of us can believe that. We are always working on data. Whenever we are on our phones, our computers, wherever we move, we are moving on the data. So this is why data mining is an important aspect of today, which has been transformed into what is called a data science today, which is going to be the future trend, or we say current and future trend of data understanding. So this is why today we even have a degree on data science, and then some certifications, diplomas, and a lot of things, because people actually, regardless of their domain of study, whether they're in engineering, humanities, social science, wherever, definitely you may need the knowledge of data science today. So data mining is the bedrock of data science. So based on according to the lesson plan, we are going to discuss some recent techniques, which one of them is the text mining. We have taken time discussing the classification, how the classification is being done, clustering, association, a lot of things. But on which kind of data do you do that? You also do classification on the text data, because all the data that we have been discussing, we can say it's a relational database or relational data sets. But actually, sometimes we find a situation where the data that you are dealing with is a text data, which is a combination of string data, like the documents. If you are dealing with your document now, your project document and your Word document, you are writing it as a form of text. So how do we analyze that text? Can we analyze that text and then derive some meaning or patterns from the data? This is what we call the data mining. So today we are going to discuss that and then see what the difference between the data mining and the text mining, as we call them differently. We say text mining here, even though text mining is derived from the data mining, but we will see a little difference between them. And then to explain types of text mining, and then to discuss the future trends of data mining, and then where we are today and where we are heading to, and then what we need to do to make ourselves actually comfortable and equipped with knowledge of data mining and data science. So you look at this slides, you see that we have about 4 different data in which we can discover knowledge from them. One is the structured data, where we have the data that has a structure. You can see the information about the home loan of the person. His name is there, the lender is there, the agency, everything is clear. This kind of data that we have in a rows and column where we have the attribute and then the attribute values. And then another kind of data that we can discover knowledge from it is the multimedia data. Today we are dealing with many multimedia data. So you didn't see any text on the data, but once you see the images, then you can easily understand what is there. So this is what you call multimedia. So today many people are into multimedia, especially those of you guys that are always on social media. Sometimes you create a multimedia with your photos, with whatever. So that multimedia actually is sound, and you can make sense out of that multimedia data. And then there is a pretext. This is what we call unstructured data, because that one has no real structure, but is information. But out of the information, we can what? We can write knowledge. We can discover knowledge. So this is why if you are reading a newspaper, you are reading a text, a pretext, but from there you can derive a knowledge from it. So that is a pretext data, which we are going to discuss about it today, how we can mine it. So you can see the information, which is similar to the unstructured data on the left-hand side. So you see the information also in this box that is under the pretext. See, Brangry's robot is home from those, so in form of information, everything is there. So you can drive, you can make a relational data. Say, oh, what is the name of the person? Is Brangry's. Who is the lender? This is MOW Financial. How much he bought it? This is the money. So you can see that it is in the form of text, but the knowledge is there that we need to see. And also today, because of the emergence of World Wide Web, we have data which is in form of hypertext. So we represent data so that this data from the link, then you can get into the particular data. So the information may be there, may be represented, especially if you are using the hypertext like HTML. So you represent data in such way. So you can see the information that we have in the beginning, every information is there. So these are the ways, these are the kind of data that we are dealing with so that we can mine and discover knowledge. So which I believe we have, we will see a lot of the information about this data. So when we say text mining, what do you mean by text mining, and what is the text mining? So looking at the definition, it's just a component of data mining. As I said earlier, so text mining is derived from the data mining. But with the advancement, see, okay, now even in text mining, maybe we have sentiment analysis, which is part of the text mining. So data mining is always, or data science is always being actually broadened into different concepts. So now from data mining, so data, then we have what is called a text mining. In the text mining, we may have maybe like sentiment analysis, for example. So all these are the text mining, but actually are giving them different names. So one text mining is just a component of data mining that deal with specifically with unstructured data, like the one we have seen in that diagram. All this data that we have seen actually is data that has no real structure. Unlike the data that we use in classification, in clustering, in association, which is a relational data, you have attribute at the instances or objects. So that one has structure. So with that structure, all you need to do is to apply the algorithm and start mining the data. So now with the power of NLP, natural language processing or natural language understanding, actually now we can be able to understand the real unstructured data. So this is why NLP now is booming this time around. So this data, actually, text mining involves the use of natural language processing, NLP technique to extract useful information and make insight from the large amount of data or unstructured text data. So what we are trying to say is that text mining actually is booming because of the emergence of natural language understanding. So this gets back to the natural language processing techniques. So nowadays, actually, computers, machines are able to understand the natural language. That text is in the form of natural language. Natural language may be in English, maybe in Bahasa, maybe in whatever language. So now you can create your own natural language processing, natural language model, actually it has to understand the knowledge, then it makes sense or insight out of the data. Whatever the large data is, now the machine can be able to understand. So this is why actually even the information that is coming to our email today, because to understand the natural language, we can see that it can analyze some of the text and then give you some options or some suggestions. So text mining can be used as a pre-processing step for data mining. You could remember even the clustering, we say we can use it as a pre-processing step for classification or as a standalone process for specific tasks. Depending on the problem, depending on the task that you want to do, data mining can be used as a pre-processing step. For example, you can use text mining, as a pre-processing step of associational mining, or as a pre-processing step of doing the clustering, for example. Because now, if you remember when we talk about association, we gave example of a text classification using the Word document. So that Word document actually you can use it as to find the association of the different words that are in the document. So you can use text mining as a pre-processing step to doing that. And then also you can use it as its own, based on the specific task that you want to solve or address. So bear in mind that text mining is part of or is a component of data mining, but actually dealing with unstructured data. So here are some of the differences. What make them to be a bit different is that they're based on different parameters. So one of them is the data object. Data mining deal with what? Numerical and categorical data. Categorical data, you could remember, is what we call the nominal data in our example, in our discussions of classification and clustering. So data mining always, those algorithms are dealing with numeric and categorical data. But for text mining, it uses textual data, which is a form of text form or pre-text information to extract knowledge. And then in terms of data structure, data mining actually is structured, while text mining is unstructured or sometimes just a little bit semi-structured, like the one we have given example before. Maybe you can see that the web text is a little bit semi-structured than the normal pre-text data. So text mining actually deal with unstructured data and semi-structured data, while data mining strictly work on the data that has structure. Structure in the sense that it has the attributes clearly, it has the instance clearly, and then have the data structure, which has maybe in the form of any of the data structure, whether it is tree. This is where we apply algorithms like the tree algorithms to extract the knowledge, or to develop the patterns, or to extract the patterns from the data. And then in terms of data representation, data mining is straightforward, because actually the data has structure. You just apply the algorithm, then manipulate the data, and then get your represent your data there. So the data representation in text mining is very complex because it is a pre-text, a raw text. So extracting knowledge there has to be complex. This is why natural language processing is applied as a technique, and then also something like deep learning technique, which is powerful algorithms, has to be applied. So in contrast with the data mining, where you can apply normal traditional algorithms in actually doing the mining. But text mining is complex, but it requires actually a powerful algorithm like the deep learning algorithms that can be used to analyze the data. And then the method of the analysis also makes them to be different. Data mining actually use data analysis and machine learning. Yes, of course. And then the text mining use data mining, then information retrieval and LLP. Because even though all this information retrieval also use NLP technique to retrieve the data. So that is the method of data analysis. So you apply the data mining concepts and then apply the information retrieval techniques or the natural language processing techniques to do the text mining. And then in terms of the age and the maturity, you see that data mining is older because the broad implementation of data mining came in since 1994, while the broad implementations of of the text mining began actually around 2000. So if you ask someone who studied computer science maybe in 1980s, he doesn't know anything about data or text mining because at that time there was no technology of natural language processing. But with the revamp of that natural language processing around that date, around 1999 today, so now we see that broad implementation starts then around 2000. And then in terms of their marketability, actually data mining actually has more than about 5 analysts at large and mid-sized companies. But today, actually, NLP, you see now, you can even just testify to that by the generative AI that is booming today, ChatGPT, Copilot, and the rest. You see that almost text mining is dominating the computing aspect today. So there is every day day in, day out, new technologies are coming up. Then analysts, corporate workers, and the individual users. Everyone today is into it, into use of text mining because what these platforms are doing is a text mining, like the ChatGPT and the rest. So this is why even the market is booming. It is even beyond tariffs for our head actually today, because the focus is that billions of dollars is coming up through the AI today. That AI actually is mainly on the generative AI mostly, and then others in the maybe robotics and others. So you see how that text mining actually is moving today. So there are some papers that can help you to know. So how do we understand the text mining? To understand the text mining, we need to understand the similarity based retrieval in text data, because that will help in understanding how the text mining is working. Especially, actually, it's a contrast of when we discuss the clustering. Also, we need to understand how the similarity is working, how the similarity in the data point is, and then what distance point are being considered in generating the similarity between the data. So also in the text data. So you need to understand how can we establish a similarity so that we can retrieve the similar data or similar information, or we can make sense or insight out of this data. So to find the similar, find similar documents based on the set of common keywords. This is one of the methods of understanding the similarity base. Sometimes you say, okay, now document A and document B, you want to see whether they are similar or not, so their keyword can be compared. That is what has been doing before. So when the keywords are compared, then it will retrieve all information that is represented. So this is what actually the Google search is doing before. Before this age, maybe you take 10 years back, when you are searching for a particular information on the web, once you type the information, so the web will just look at the keywords and then give you similar or related items. This is why at that time you see a lot of queries. Maybe you are looking for a particular information, you see maybe thousands of queries. But today, because of the advancement of technology, it went ahead to understand the concept of the context of what you are searching for. Today, even AI can even give you suggestions. So this is how the similarity is. So actually, common keywords, what are the common keywords? So if I'm looking for a particular paper about the machine learning, when I type in machine learning on a so domain, then all the machine learning data that is online, then to just look at the keywords, and then this is why we are publishing paper, they will ask you to identify the keywords, because that is very important. For what? To have profile view of your publication. So you see that anytime you are reading an article, below the abstract, you will see the keywords. That keywords are what will help them to identify the related information or related data that is relevant to the particular search. And then also its answers should be based on the degree of relevance based on the nearness of the keyword or relative frequency of the keyword. So we request want to retrieve the information based on the similarity base. So the result that you are going to get is based on the relevance of that, the relationship, how associated, how closeness, how nearness these data are, these the keywords are. So this is why actually the keyword search is very important. But today actually even the web is going beyond the normal traditional keyword searching, because it's what is called an intelligent query system, so that you can ask for the information and then to give you exact information that you are looking for, or maybe use a very high precision. So what are the basic techniques that are being used in this similarity-based retrieval? One is a stop list, actually looking at a document. So just consider bear in your mind that we are considering a document that has information flow, like your project document. So this stop list actually consists of the set of words that are deemed irrelevant, even though they may appear frequently. So whenever you want to do that, the first thing in preparing the data, actually, you have to look at the stop list, stop words, and start thinking of what. This is why in pre-processing of the text, preparing the data for text mining, sometimes you have to remove all the stop words from the data, because stop words are irrelevant in your mining. Oh, it is clear. So sometimes actually, as we are always saying, if so like in the classification, you want to do the classification, sometimes you just remove the ID from the data because it is the relevant data. This is why we even have the select attribute, where we can select the relevant data, which is also relevant attributes that are related to our analysis. So in similarity-based retrieval, actually, stop lists are what? Stop words are irrelevant. So we have to what? Create a list of those stop words. What we call stop word is a word that, like the articles, some of the connectors, and the other things. So all these are the stop words, like a, the, of, for, to, with, and so on, but, and the rest. So all these are the stop words that has to be removed and then created a list for them. So stop list may vary when document set varies. Depending on the document, then you may have different stop list. Another technique is the word stem. What do we call the word stem? Several words are small synthetic variants of each other, since they share a common word stem. What do you mean by the word stem? Is the origin of the word. For example, now is okay. This example is drug. When we say drug, actually we can have drug with S, drugs. We can have drug as a past tense with ed, drug. So all these actually are what? The stem. The origin of the word is a drug. So this is what is called a stemming. The word stemming actually is also important. It has to be understood, and then how it can be dealt with. Okay, comes, came. So all this has the same origin. So this has to be also considered. And then also the what you call term frequency table. How many times that particular words occur in item on document A and then document B, for example. So each entry frequent table of AIJ by the number of occurrences of the word TLI in document D, I. Usually the ratio instead of absolute number of occurrences is used. For example, now you have a document, you have a project document about the data mining, for example. So now how many times a particular word called data appears? That is what we call the frequency. So maybe the word data appears in that document. Maybe it is 10 pages, maybe it may appear like 100 times. So instead of counting those, the ratio is taken, the ratio of the occurrence of that data is used, based on how many times it uses. So the absolute number is not considered. Maybe you take the ratio, maybe data and the information may appear in maybe 2:3. Maybe say, okay, now data appears 50 times, while data appears 100 times, while information appeared 25 times. So say, okay, now this is the ratio of their occurrence. So this is the term frequency. So the table is also created for that. So this is why actually initially we said actually that dealing with the text data is complex. So this is why those that are working in LP, you have to think of the powerful algorithm to apply. And then similarity metrics, or how do we measure the similarity? That is the measure of the closeness of document to a query or a set of keywords. So when we are comparing different documents, this is actually this similarity matrix is what make something like the Turnitin to give you the similarity. So now to compare the your document with the other document on the web, and finally they will tell you, oh, this is a percentage. Maybe there is 50% similarity between your document and the web document, or there is 70% similarity with your document and the AI generated text. So this is how it actually appears. All this is a form of text mining. That's what we give birth to all these systems or applications that we are using today to check the plagiarism and the rest. So similarity matrix also is important. So there's certain techniques that need to be understood whenever you are dealing with text mining. One of them is the relative term occurrences, how many times the related terms appear. Then the cosine distance, which we have discussed during clustering, which is the distance between this word and this word. The distance will determine their relationship as we did in the clustering. So if the distance is very far, it will tell you, oh, they don't have any relationship. But if they have closer distances, then now they have relationship. Or use the relative term occurrence, how many times they appear based on the frequency table generated. So all these are the techniques that combine the measure. So relative term occurrence, okay, now this is the ratio of the occurrence of document A and document B. This is the ratio of the occurrence of the data. The word data appears in document A 100 times. The word data appears in document B 50 times. That means 2:1. So this is the ratio. But for the cosine distance, you're okay now, maybe using the cosine distance, the similarity between V1 and V2, that is document 1 and document 2, is just the dot product of document 1 and 2 divided by V1, absolute value of document 1, number of document 2. If you could remember in the document classification we did actually we use this similar formula, and then you'll also see another example in the subsequent slides. So this is how we can find the similarity using the cosine distance. The distance that will give you, okay, now based on that, say, okay, these items are similar. So what are the types of text mining that we have? So do we have any question on the big background so far? Any question, please? Can we move on? Yes. So, okay. Okay, the types of text mining. One is a keyword-based association analysis, as I have discussed earlier. So we actually do text mining based on the keywords. What are the association? What are the relationship between the different words, keywords in the document? And then automatic document classification. Yeah, classify document based on using the particular algorithm. Then the similarity detection also is another type where we can cluster document by common auto. For example, cluster document containing information from a common source. For example, now I have published many papers, so my name is there. So if you are looking for the date for a particular paper authored by me, this is why even where you can usually search your articles, you can see that there is filters. So you just search by author, then you see all the papers that are published by a particular author. So this is the similarity detection. So they will detect the similarity and then give you the result. And also maybe the similarity detection that we are being used in Turnitin, in similarity checking softwares and the rest. All this is what is trying to find the similarity between the item. So to cluster at document containing information from a common source, that is what the similarity checking software is doing. And then another type of text mining is link analysis. unusual correlation between entities. So if you understand what linked data is today, due to the emergence of World Wide Web, as we said earlier, you see that the data are linked together. So data can be linked at the ontological level. So that actually even the semantics of that data, the meaning of that data can be connected at the ontology level. So this is what's called linked data. So link analysis actually can be used to find unusual correlation between different entities. And then sequence analysis, predicting a recurrent event, which I believe we discussed sequence analysis during discussion of clustering a team, like the DNA sequencing and the rest. And then anomaly detection, find information that violates usual patterns, like the use of credit cards and other methods. Then text mining also can be used. Another type of text mining is to find anomaly detection. If there is any anomaly in the document, then the information can be that violate the pattern can be detected. So the first one is the keyword-based association analysis. So the motivation behind this is to collect set of keywords or terms that occur frequently together and then find the association or correlation or relationships among them. Yes, as we have said earlier, if we want to, this is why in the papers, we always identify the keyword. So this keyword can be used to find the association or relationship between this item. So this is why if you are searching on a particular paper based on your search parameters, then you will see a lot of papers that are closer, and even some suggestions tell you, even the web can tell you, okay, now these are the related papers that you may also need beside the one that you have seen in the query result. So association analysis process, I think you don't need to go back to association analysis. We have discussed association analysis. The process is process the text data by passing. The only difference between this one and the next one that we did, the last association analysis uses structured data, but this one actually uses unstructured data, which is a raw text. So the first process is what? It's the process or pre-process. You can say pre-process the text data. As we know, actually, whenever we want to do data mining, we have to do some pre-processing. In classification, we do discretization, we do normalization, we do a lot of things to make sure that our data is what? Okay. Like the handle outliers, maybe replace missing values and the rest. So in text mining, the first pre-processing you want to do is what is called parsing. Parsing is one of the pre-processing method in text mining. By parsing, we mean that looking at the sentence, that sentence has a structure. So what are the components of that sentence? It has to be broken down. Okay, I am going to school. I'm going to school is just a sentence. So, but I is another thing, is one thing, is one thing, going is another word then. So what is it? Is this an article? Is this a verb? Is this a noun? Is it a pronoun? All this has to be broken down. This is what is represented as parsing. So in training the model has to understand that. This is why actually I said earlier, text mining actually, as it requires the application of natural language processing, it also requires public algorithms, because those algorithms have to understand a lot of concepts. Even the words that you are going to train the model with, you have to look up all the synonyms, sometimes many alternative synonyms and phrases that can represent a particular word for you to get the very reliable model. And then also stemming, as we discussed earlier, the word has a root, for example, drug, drugs, tract. This is also another thing. So you have to do all this pre-processing and make sure that this has been identified. Then removing stop words, which we have discussed earlier. Stop words like articles, A, D, for. What these are the stop words. So they have to be removed from the document. And then the next thing is to evoke association mining algorithm, any algorithms that you are going to apply. Then consider each document as a transaction. View a set of keywords in the document as a set of items in the transaction. Then term level association mining. No need for human effort in tagging documents. The number of meaningless results and the execution time is greatly reduced. So this is just the process of doing the analysis, starting from the pre-processing up to the level where you have gotten the result. And then text categorization. Another method of text mining is text categorization, which is like the classification. So this is a classification process. How to do also the data pre-processing, a definition of training set and test sets, as we did in the classification method. This is why we said text mining can be used as a pre-processing step in text categorization. And the creation of classification model, which model to be used for classification, validation, and then finally classification of new or non-text document. Now, this is a classification, so we can use to classify different documents and then use it for prediction. So this is a process actually similar to the process of normal classification, pre-giving categories and the level document examples. Categories may form hierarchy, classify new document, standard classification using the supervised learning method or problem. So the diagram is indicating the process, which is this process is almost similar to the normal classification, but this one is dealing with text data. So we have the set of data here with different methods. So like the categorization is used now in the news. This is why if you are checking the newspapers now, even online, you see that the newspapers are categorized according to their what? The domain. So no longer, before news is just like that. But nowadays, if you are watching news online, you see that you want to then sport news, you just go to the sport category or sport class. Then just click and open all the sport news. Or if you want to watch or want to view the business news, just go to the business news category. Then by clicking the business news category, then you see all the information, all the news about what? About the business. So this categorization is what the newspapers today are using, especially the online newspapers. They categorize the news based on the what interest. If it is education, if it is business, if it is sport, if it is finance or whatever, then you will just see it clearly. So this is how the model is working. Get the data about all different classes or different categories, then process it with the algorithm, and then classify them according to their domain. So when the news is coming now from here as error news, actually initially, so the model didn't know that this is sport news. But based on what you did actually in training the model, you train the model that with a particular keyword. Say, okay, now, once so keyword is in this document, categorize it to be in what? In sport news. When there are so keywords in this particular document, categorize this to be what? A business news. So this is what they are using. So now the algorithm can look at the keyword, analyze all the text, and then, okay, now this is supposed to be what? This. So this is why actually now, wherever you want to send, for example, an email, once you didn't put at, if there is no at is a key term in an email. So definitely to reject is telling you that this is not a correct email, because that at is what? Is now based on the NLP. Everywhere is defined to be the term that is associated to what? To the email. It's a special term with special character used for email. So if it is missing, so definitely that is not considered as email. So this is why even the emails we are receiving today, you see that as the email document is coming, some are what? Classified to be in a spam folder, because it is not trusted by that particular email. So now it is not going to your inbox, because there are certain keywords that they use to recognize that this is the correct email, especially now, any email that is coming, if you are using the official email for UITM, for example, if any message is coming from outside the UITM, sometimes they have to send it to the what? They send it to spam until you go and what? and then agree that it is not a spam, then you see it in your inbox. So that is it, because it recognizes the domain of UIT and okay, this is an email, official email, because it has an official domain of education. So any communication within that, this is why some, if you want to do some registration sometime, they can even ask you to use the official email, because that is actually giving them a lot of opportunity to avoid maybe unnecessary emails coming to your email or scam emails. So this is what they do actually to recognize a scam that is coming to our emails, coming to our messages. So there are some certain terms. So this is how the text categorization is working. Just divide the data based on the understanding of the text, then it will group it into respective class or category. So maybe in Weka, you can do text mining. Maybe you can try doing some text mining in Weka, find the text data, and then try some of the algorithms. It's simple. It is in the classification. You can have the filtered classifier there. So even though we are not going to do any lab exercise on text mining, and then document clustering. Text mining also can be used for document clustering. If you remember, we talk about the document clustering, but actually text mining can be used as pre-processing step of other data mining tasks. So like the classification, document clustering, and the rest. So it is used to cluster document based on their clusters, which is similar to categorization. Now you see that it's categorized, when used is categorized. So the motivation is that automatically group related document based on their contents. And then no predetermined training set or taxonomies or generate a taxonomy at one time. So if you remember now, look at this, manually, we usually cluster our documents. For example, now, you are taking different courses, ISP, for example, ISP565, ISP611, ISP5666, for example. So in that, you manually make a folders. That folders is what? Based on the courses. Any document that is coming, any document that you receive now, like the lectures, assignments, whatever, you put it in what? In ISP565 folder. So that means manually you are creating your own clusters there. So maybe inside the whole one folder, for example, semester 2025 to 2054 semester, for example. So now inside that folder, you have different folders also. That is a folder of that folders. Those folders also contain different courses that you are offering this semester. So any document about ISP565, you put it in the folder. Any document about ISP611, you put it in there. About ISP650 or 640, you put it in there. So all this, at the end of the day, you see that you have one folder, but inside that folder, you have all your courses. So that means manually you are what? Creating a cluster. So what the document clustering is doing using the text mining, to do it automatically. Whenever a particular document is coming, the document is analyzed. So, okay, now, based on the analysis of the document, there are similarities of the words. To compare the words, the document in your folder, oh, all this document is containing ISP565. This one is containing ISP565, though they have the similarity. If the similarity level maybe is below or beyond the threshold, then it will just put it into that group. So that is the motivation behind that. So instead of to address the problem of doing that manual processing or manual grouping, so the document clustering is used to automatically relate documents based on their contents. Then no predetermined training set or taxonomies in this case, and then to generate a taxonomy at one time. So clustering process, how does it do it? Actually, it has to do the pre-processing also. If you want to do it, you need to do the pre-processing, remove the stop words, do the stemming. So you see the pre-processing step of the text mining almost in every aspect is going to be the same. The first one, we say we have to remove the stop word, we have to do the stemming, we have to add. But in this case, there are what is called the feature extraction, which has to be applied, lexical analysis, what are the lexicons of the data, so that it can be what grouped into that particular cluster, and so on. And then hierarchical clustering can be applied, compute the similarities, applying clustering algorithm. We don't need to go back and discuss hierarchical clustering. Then model-based clustering, like the neural network approach, can be also used. And then cluster represented by numbers like SOM can be used for represent the clusters. So especially nowadays, actually, if you are dealing with the text, sometimes you recommend using the model-based clustering, using the neural network approach, because it is more powerful than traditional hierarchical clustering. So that is it. So this is an example of cosine similarity, which we have discussed earlier. I think we have discussed this slide during discussion of clustering. You can see the different documents, like 4 documents here, team, different words has been extracted from the document, team, coach, hockey, baseball, these are the keywords, soccer, penalty, score, win, loss, season. So how many times this appears? In document 1, team appears 5 times, in document 2, it appears 3 times, but does not appear in document 3 and 4. How many times the word coach appears in document 1? 0. Document 2, 0. Document 3, 7 times. And document 4, 1 time. Continuously, then you have all the important keywords from that particular document. Now you want to compare different documents. You want to compare 2 documents. So the similarity cosine, I think we have discussed this. We don't need to waste time on it. So you can have the cos, that is the numerator of the formula, where we have the product, document 1, document 2. Then the denominator is the absolute value of document 1 value, and then document 2. So this can be what? Defined by what? Document 1 and 2, what are the similarities? Then you extracted document 1 and 2 from the table. Then you look at the document 1, what are the occurrences? 5, 0, 3, 0. Continuously, you have the total values. So you get the dot product using this formula, and then finally get the final value as 0.94 as the similarity, which is 94%. So that means document 1 and document 2 has that similarity. So exact values of trigonometric functions are here. Just create a table and then find out what similarity you get. Then at the end of the day, you conclude that document 1 and document 2 are similar documents. This is actually sometimes what the similarity checking systems are using to find out that there are similarities. The percentage of similarity is high. And then another type of mining, the text mining, is mining the World Wide Web, which is using the hypertext data. So what are the challenges in the mining the World Wide Web? The web seems to be huge for effective data warehousing and data mining. Yes, this is why we are into big data today, because the web, actually, the data is always coming, because the data has no structure. So a day in, day out, the data is being increased. And then the complexity of the web pages is far greater than that of any traditional text document collection. Of course, the web pages now are complex. You see that they are even nested. Actually, sometimes you have a page, then inside that page you have many pages continuously. So because of that complexity, mining the web actually is becoming. So this is why today actually you do what is called linked data analysis or semantic web technology. Semantic web technology actually is trying to address the web mining concept by making sure that the algorithm understand the context. So instead of visiting everywhere, just look at the context of the information. So that is the meaning. I think this is what the AI is trying to do, is doing now, like the ChatGPT. Once you ask the question, it will give you direct answer because it understands the context of what you are trying to ask, especially if you are giving it a powerful information. So because if you want to get the best answer from the ChatGPT, for example, you need to be specific on what you want it to give you so that you can have the correct or right solution. And then the web is highly dynamic information. Yes, the sources are very dynamic, it's not static. So you can have different sources, the same information from different sources. This is the essence of doing the link, what is called a link data. Instead of reinventing the wheel, instead of having different data. So the data that is already there, why not to link it together so that whenever you need it, you can extract it from the web. So only a small portion of the information on the web is truly relevant or useful. That is correct, actually. The information is very huge on the web. And then what you need for your analysis is very, very small portion. So this is why mining that is very difficult. So you need powerful algorithms to do that. And then what types of web mining do we have? Different types of web mining. One is the web content mining, and then web structure mining, and then web usage mining. Web content mining is dealing with the patterns through web crawling. That is downloading the data, real data from the web. So web content mining is what usually we do. We mine the web content, like what the Google is doing. Google is trying to mine the content. So you just give a command to Google, then it will look at different contents and then give you the result. And then also some mining may involve the structure, that is patterns through nested web pages through hypertext. Sometimes we'll give you the links. So by hyperlink, then you can go. This is why if you are reading an article, you can see the hypertext, the references, for example. So that means this one is a web structure mining. So from the paper you are reading, you can click and then you can move to the page where you can get another information about that, or you can get the data. For the reference, you can see the DOI of the paper. You just click and then it will take you to the web. So all this is the pattern through nested web pages. Inside a particular web page, you can see another web page, and you can see another web page continuously. This is what is called nested. So this is what is called web structure mining. And then also web usage mining, which is a pattern through the server logs. Actually, that one, especially if you are running the server. So at the server level, they use what is called web usage mining to relate different information. So this is why you see that maybe the domain of this, you are using the UITM internet, for example. So there are certain contents that you are not allowed to maybe access using that particular. So some organizations are like that, they block some certain content because they always look at the server logs and see what kind of activities is taking place on that particular network. So they can specify a certain keyword. Whenever you are searching something related to that keyword, definitely it will be blocked. So all these are these. So they use that also to identify anomaly and the other things, or detect some intruders that are coming to their network. So all this is a web usage mining because it is just behind the scene, especially for the source that are web administrators. So these are the types of web mining. So this is the web usage mining process. How to do to? You can see that different server logs there. Then from there, domain knowledge, site content structure. Then to move to the web application is there, and the server, data pre-processing, data cleaning, page view, identification, synchronization, data integration, data transformation, then user transaction database, then they check the user transaction database, then usage mining, for transaction clustering, page view clustering, correlation analysis, social rule mining. Any of these can be applied to do that. Then the patterns is what is detected from there. Then the patterns are filtered, like the aggregation, characterization, and the rest. And then finally aggregate user model, and then produce the results. So that is how it is. So the data preparation phase, actually after it finishes, it's to go into the pattern filtering and then finally discover pattern. So it has two phases, data preparation phase and then pattern discovery phase. So this is how the web usage mining is working. Most of the times this is being done by web administrators. Web administrators are monitoring this, and then they are mining a lot of data content, and they use that to actually to protect or to prevent intrusion into the network, by classifying different content that are coming from the user. So all the transactions that user use, then they have to mine it, they have to do it. So this is why whenever you are on network, you make sure that you are not safe or you are not secured. So because someone, maybe the third party is there actually monitoring whatever actions are using, or they are monitoring it based on this. This is why even now, if you log into a particular, now you want to log into a new system, for example, using your new phone. Once you log into your Google account, for example, you receive an email telling you that maybe someone is attempting to log into, or attempting to log into your account using a new device, for example. I believe you have seen a lot of information about that because this web usage mining, they are trying to monitor whatever is working. For the Google, Google can even go ahead and tell you the location. You are logging in Salango, they'll tell you, oh, now there is a new login in your account from Salango. So you have to ask if it is you, then you say, okay, yes, it is me. Otherwise, you take appropriate action and inform them that it's not you, it is an intrusion. So this web usage mining is used now today to what? To detect all the intrusion. And then social media mining, yes, as we said today, we are into the era of social media. So now we apply the concept of text mining to do the social media mining because we are trying to extract or analyze the text. So social media, there are a lot of social media platforms today. So this mining actually is a process of representing, analyzing, and extracting meaningful patterns from the social media data. This is why today we are doing what is called sentiment analysis. Take Twitter or Facebook, whatever, look at the comments, analyze the comments, and then come up with a solution decision based on the comments. So this is what is called social media mining. Social media analysis from Twitter, which is a sentiment analysis, for example. Finally, you say, okay, this comment is positive, this comment is negative, or this comment is neutral. So these three measures can help us to identify the comments. So this is social media mining. Call it sentiment or opinion mining or sentiment analysis. So this is a process from any of the social media, Twitter, Facebook, whatever it is, LinkedIn, then any media that may involve a comment and then sending some text messages, because in that comment, actually, everyone has his own words of comment that he can read. So the other special words or keywords are extracted from there. What words are considered to be positive? What kind of words in this comment are considered to be negative? What kind of words are considered to be what? Neutral words. So this is why it's very important. And then even today, if you are use the social media, you see that in Facebook, sometimes you want to write, there are some certain words that are defined to be abusive words on social media, so you cannot use it. If you want to use, you have to change some certain parameters, certain terms in that word. So because actually that platforms are what? Detecting that abusive words, social Facebook, Twitter, whatever. So because of the NLP, the power of NLP, they identify some words to be the abusive word based on the sentiment analysis they are doing. So based on that, you can say, okay, now this comment is considered to be what? To be positive, considered to be negative, considered to be neutral. So if the data is coming, to start with the pre-processing also, removal of what? URLs, because actually to do the sentiment analysis, all the URL of the data has to be removed. Filtering of repeated words, and then which questions do you want to ask? Then special characters has to be removed also. Emotions, yes. Sometimes if you want to use emotions, you got to know that, okay, you have to define that source of emotion, because sometimes somebody may comment with the emotion, not a text. So maybe you have to remove them from the data, or you define them, you know their definitions. This emoji, for example, some are what? Thumb off, you know, okay, now this thumb up is positive, maybe thumb down is negative, or whatever. And there are tweets, yeah, there are tweets from there, finally, after the pre-processing the tweet, apply the machine learning algorithm, whatever machine learning algorithm you apply, do the classification, then classify the comments based on positive, neutral, and the negative. So finally, you have the result of the classification. That classification will tell you, okay, now, so percentage or so number of comments based on the comments we analyzed, so percentage are positive, so percentage are negative, so percentage are neutral. This is a sentiment analysis, trying to understand the opinion of the people from their posts. Then the challenge, what are the challenges of social media? Because we need to understand the challenges so that we can improve further, especially you are the computer scientist now, you can think of, okay, now solving some certain problem. Big data paradox, yes, social media data is very big, yet not evenly distributed. Up to little data is available for an individual, yes. So whenever you are dealing with big data, so definitely that requires a powerful algorithm, and then maybe you can have a little data about particular task you want to do. And then obtaining sufficient sample, a sample's reliable representation of the full data, that is another thing, because whenever we are dealing with data is just a sample. So is this sample enough to represent others or represent the whole information? Maybe if it is about the sentiment analysis about the vote, maybe you just go to the page of a particular candidate, extract all the comments. So can that be used actually to represent the whole Malaysia, for example? So that is another issue. And then noise removal, there is a problem with noise removal. Too much removal makes data more sparse. Yes, because sometimes social media data is full of noise, and the noise definition is relative and complicated and is tax dependent. Because sometimes, if you remember when we do the association last week or this week, you see that the data that we use, the transaction data, somebody may say, oh, there is a lot of missing values. Yes, of course, but in the context of associational mining, it is not a missing value. It is not transaction there. That is, it is a transaction that is no transaction. But in the context of classification, we say, oh, this is a noise, this is a missing values. So this is why we say, okay, now noise removal is depend on the context actually. And then evaluation. Up to now, actually, there is a dilemma about the evaluation. There's a lot of issues when there is no ground truth. How can you evaluate the model? If there is no existing work to compare, how can you make sure that this model that you are developing, the accuracy you get, how can you evaluate it? Because sometimes for us to evaluate our model, we need to have a ground truth. That ground truth will help us to compare. Okay, now what is considered as a ground truth? That maybe we have 70% accuracy, and then it is widely accepted that when you do the sentiment analysis, we have the accuracy of classification as 70%, for example. So now that ground truth and accepted widely by the scientists, now you can use it to, okay, now we want to compare to make sure that our model is beyond that 70%. So this is another thing. So this is why a lot of things needs to be done, even though there are ongoing researches on this. So what of the multimedia? Another type of text mining is multimedia data on the web. So how do we mine multimedia data on the web? Because the web is not all about the text data. There are also multimedia data like the video, audio, images, and graphs. When you open the website now, you see a lot of this. Beside the text, we have images, we have audios, we have videos, we have a lot. How does this be mined? So a web page can be partitioned into a set of semantic blocks, and then block contains multimedia data. Searching and organizing the web multimedia data can be referred to as searching and organizing the multimedia block. Surrounding text can be used to build an image index. I think these are some of the things that this generative AI are using. This is why you ask them to generate an image for you. You see them, they are starting with the text, they analyze it, then look at the steps surrounding the text, then come up with the image. So for this mining of the multimedia, I had to start with what? Creating your blocks by partitioning into set of semantic blocks. That's where the blocks has particular meaning. So this any block, each of the block is containing what? The multimedia data, particular multimedia data. And then this searching and organizing is what is referred to as like a searching of the organization, organizing the multimedia. Then at the end of the day, all the surrounded text can be built as an image. So also for the audio data mining, it uses data as audio signals to indicate the patterns of the data or the features of the data mining results. This is why you are playing the audio now, you see the pattern signals moving. And then interesting alternative to visual mining, an inverse tax of mining audio such as music, database which is to find patterns from audio data. So visual data mining may disclose interesting patterns using graphical displays, but requires users to concentrate on watching patterns. Actually, all this is just about what? Looking at the pattern of the data. This is why when we visualize the data as a graph, you see that we see the pattern of the data, especially when you cluster the data or you group the data, you see the visualization. Even in Weka, you can visualize the data. So this is it. But actually, for the audio, it uses the signals to indicate the patterns of the data and all the features of the data mining results. So instead, to transform patterns into sound and music and listen to pitches, rhymes, tunes, and melody in order to identify anything interesting or unusual. So this is why actually there is serious need of strong algorithm to do that, because it's the algorithms. This is why today most of this analysis uses deep learning technology, because this learning algorithms, because those algorithms are powerful enough to go deep into different layers and then extract patterns layer by layer. So sometimes traditional algorithms cannot do this kind of analysis because it requires a lot of things. It has to listen to the tune, the melodies, and the rest, then come up with a solution. So visualization, use of computer graphics to create visual images, which aids in the understanding of complex massive representation of data. So how to do the visual data mining, the process of discovering implicit but useful knowledge from large data set using visualization techniques. I believe we have seen that using the visualization even in Weka. Then you can do the data mining, visualize data mining using the computer graphics, multimedia systems, SCI, high performance computing, pattern recognition. With all this, you can do the visualization, because nowadays, see that you can even do the pattern recognition to find pattern out of the images. So all this is a visual data mining. So what are the research problems in text data mining, in text mining? One is a Google. What is the next step? For example, how to find the pages that match approximately the sophisticated documents which incorporate of user profiles or preference. So this is why up to now, maybe you can see the Google search is incorporating AI method, because it is heading to intelligent search nowadays. From the traditional search to intelligent search that can give you, actually that can incorporate all the documents and then give you a powerful results. So that is it. So this is one of the problem in text mining. Actually, what is going to be done? Maybe you can take up it as a student for further studies. Say, okay, now how can I bring something? Look back at Google, for example, inverted indices, construction of indices for the sophisticated documents, whose cooperation or user profiles or reference, similarity search of such pages using such indices. Yes, all these are the problems in text mining, especially when it comes to the search. So these are the problems that Even though actually the company like Google is trying a lot to see that they solve this kind of problems. So maybe I'll give you 5 minutes before we continue. Already four, so we'll continue at 4:20, right? Are you with me?
Yes, sir.
Okay. So I'll give you 5 minute break.
All right, sir.
Okay. Okay, are you back? Shall we continue?
Yes, sir.
Okay, so actually from what we have learned so far throughout these 12 weeks, we can say that data mining has a wide range of application as an interdisciplinary field. It's wide and diverse applications or application domains. There's non-trivial gaps between data mining principles and domain-specific applications. So what we are trying to say is that you can apply data mining in almost every domain that you may think of. Actually, you can apply data mining today. So this is why understanding the concept of data mining, and, having the knowledge or skills about the data science is important today. Not necessarily that you are going to work as a computer scientist, no, you can work as a data analyst in a lot of industries and a lot of organizations. So it is, as we said, as interdisciplinary, so it can go anywhere. It has no border. Data mining has no border. You can apply it in almost everywhere. So some of the application areas can be financial data analysis, hotel industry, telecommunication industry, biological data analysis, and the rest. So in financial data analysis, we can look at the financial data collected in banks, in financial institutions, and offer relatively complete, reliable, and of high quality. Then you can design or construction of data warehouses for multidimensional data analysis and data mining. So from that data, you can do the depths and revenue changes by month, by region, by sector, and by other factors. So data mining can be applied to that financial data for that. And then you can also access the statistical information. So there's a maximum, minimum, total, and average, the trend of the data. And then what are the loan payments? For example, if you are dealing with financial data in the banks, you can also do the prediction on the loan, with consumer credit policy analysis. So a lot of things you can do it with the financial data analysis. You can also do classification and clustering of customers for target marketing. Yes, with the data. Then you can also work on the classifying or cluster grouping the customers based on their transaction behaviors, or based on their capacity or capability, based on the savings that they have in your bank. So you can have a multidimensional segmentation by using the nearest neighbor algorithms or classification algorithms, decision trees, and so on to identify customer groups or associate a new customer to an appropriate customer group. And then also it can be done to do the detection of money laundering, fraud detection, for example, money laundering detection and other financial crimes. So a lot of things actually, when there is a data, then there is a possibility of analyzing that data and do the needful. Integration of multiple databases, bank transaction, federal, state crime history, can integrate the data information with the national data or federal data or state data. So we can visualize, can do the linkage analysis and the rest, and outlier analysis and sequential pattern analysis to find unusual access sequences. So when there is an unusual attempt, then we can use financial data to, this is why if the credit card or the ATM card is stolen, once the password is used wrongly, they can easily detect because they detect an unusual pattern. So in retail industry, data mining can be applied to huge amount of data on sales, customer shopping history. You remember we use market basket analysis to do the association, to understand association role mining concepts. So we can apply, identify customer buying behaviors, discover customer shopping patterns and trends, improve the quality of customer service, archive better customer retention class satisfaction, enhance good consumption ratios, design more effective good transportation and distribution policies. All these are the different areas in retail industry where you can apply data mining. So it's just left for you now to go deep into a particular domain and understand, okay, how can I create my own maybe small company to start doing the data analysis for the companies. For example, retail analysis, you can design or construct a data warehouse based on the benefits of the data mining. Multidimensional analysis of sales, customer, product, time, origin. Another example, analysis of effectiveness of sales campaigns. Another example is customer retention, where you can analyze customer loyalty, whether the customers are loyal or non-loyal now with the customer. User customer loyalty card information to register sequence of purchases, particular, use sequential pattern, or suggest adjustment on the pricing and variety of goods, because based on the analysis, you say, okay, now some certain customers are not loyal to our company, so you need to adjust some certain prices. Maybe they are getting more subsidized price in another from our competitors. So all this can help to understand or to do the customer retention analysis. And then purchase recommendation and cross-reference of items. Okay, so in telecommunication industry also, we can apply data mining, which because telecommunication today is rapidly expanding and highly competitive industry. And there is a great demand for data mining because they need data mining to understand the business involved. They need data mining to identify the communication patterns. They need data mining to cut fraudulent activities. They need data mining to make better use of resources, that is resource utilization. They need data mining to improve the quality of service also. So all these are the way that communication actually you can apply data mining into the communication industry. As we are always saying, this multidimensional analysis of communication data, calling time, duration, location of caller, location of callee, time of call, and so on. All these are the data because whenever we are making that, actually it is being recorded. So if you call your friend, this record is there. So this is why actually even the security personnel, security agencies nowadays, they are using the telecommunication to identify or to reach out to some offenders, especially in a very big crime. So what communication they do, and then they can easily trace the communication and the location of the communication, so that they can trace the crimes. So a lot of things. And then also we can do fraudulent pattern analysis and identification of unusual patterns, as I said now. Identify potential fraudulent users and their typical user pattern, discover unusual pattern which may need special attention, unusual pattern in the calls, maybe there is observation of that this call actually is harmful, they may cause problem to the society or to the particular community, then actually take appropriate action. This is a fraudulent pattern analysis. So find user of patterns, use of visualization tools in telecommunication, data analysis. So all these are the ways that you can apply data mining in telecommunication. So for biomedical, I think we have discussed DNA sequencing in the class. So there are 4 basic blocks, nucleotides, adenine, cytosine, C, guanine, G, and the thymine. All these are the classes. So sometimes we can classify the sequencing data based on these 4 building blocks. And then a sequence of 100 individual nucleotides arranged in a particular order, sometimes a gene in the body. This is why DNA sequencing is being done in the hospital. Sometimes there is a complication about the genuineness of the father of a particular son. They do DNA. From the DNA, they will compare the sequences. So, okay, now the DNA of the father is the same as the DNA of the son. So at the end of the day, they conclude that, take decision that this is his son or this is not his son. So this gene actually is and so as humans, we have around 30,000 genes in our body. So DNA sequencing can help us extract the sequences. Tremendous number of ways that these nucleotides can be ordered and sequences to form distinct genes. And then semantic integration of heterogeneous distributed genome database, because today genome database is used to identify diseases, for example. So you can use this genome data set to mine the appropriate to do the right mining and then discover some diseases that are available using the DNA. So highly distributed, uncontrolled generation and use a wide variety of DNA data. So it involves data cleaning also and data integration method developed in data mining will help. So as we said earlier, actually you can apply data mining in almost every wide area of applications to find a possible solution. For example, also examples of DNA analysis, similarity search, and comparison among DNA sequences. It uses to compare the frequency occurring patterns of each class, that is disease health, or health. For example, identify gene sequence pattern that play roles in various diseases. What kind of gene is responsible for a particular disease? Then you can use DNA data to analyze and then come up with a solution. Then you do association analysis, identification of occurring gene sequences. This will make, actually, as I've given you example between the father and the son, to make sure that, okay, this child is a child to a particular father, based on the association analysis between the gene of the father, DNA of the father, and DNA of the child. So more disease, and then also for some diseases. So more diseases are not triggered by a single gene, but by a combination of genes acting together. So we look at the association between the genes also, find out that how many different type genes can trigger a particular disease. So that is it. And the association analysis may help to determine the kind of genes that are likely to go together in target samples. Yes. And then visualization tool and genetic data analysis is also help in this. So that as a recap, actually, there are a lot of areas where you can apply data mining. Just to recap some of the major areas, which I think will cover a lot of, like the finance, the communication, biological. Actually, will have to cover a lot of areas in applying. So also you can apply it in doing some optimizations in that. And then future trends. What are the future trends? What are we expecting actually in the future? Because now you know that we understand what we have currently, what we already have on ground, and what we are being done. So we need to have the domain space publication, including biomedicine, DNA, finance, retail, and communication data mining. So important applications there. We may need some applications that can help us to do all this. And then since there is a data mining system, and it is important to know their power and their limitations. Yes, with the existing ones that we have, okay, now how can we know their power and their limitations? That means we need to have the validation methods in the future. And then visual data mining, which includes data visualization, mining results, visualization, mining process, visualization, and the interactive visualization. Even though today I think there are some visualized, like the Power BI. Sometimes you can use Power BI to do the interactive visualization of data. So the data analysis, as currently you can see, you can visualize everything. So that today there are even some applications that can do that in the systems, but even though they may require more extension or improvements. And then also intelligent query system, locally answering, can be integrated with mining. Even though today, as some of the search engines like Google, they also have intelligent queries, they exhibit intelligence, but more need to be done actually to make it more and more intelligent query system. Whenever we are searching for a particular document, then it will have to read the context and then give us solutions. So it is important also to look at the privacy and security issues in the data mining, because now we can analyze the data like sentiment analysis and this. What are the security issues associated? And then what privacy measures need to be taken so that we can prevent the data that we are using. Because whenever we are dealing with data, privacy and security has to be taken into consideration. So take note and bear in mind whenever you are dealing with a particular data, especially some data actually need to have the consent from the data administrators. So this is why during a project, you have to fill the ethics form sometimes, you have to fill this and that, and you have sometimes, some cases, you need a data from the hospital, you need to get a letter, introduction letter, then they can give you the data because there are some certain privacy in that data set. So this is very important. So we have to think of how to protect, how to solve this problem of security. So what do we need to do? You need to actually have the skills of being a data scientist. Because look at the data mine now, it is transforming into the data science. So these are the skills that you need. Actually, this course has often do for you to understand some basic concept and then think ahead and say, okay, now what and what do I need to so that I can become a data scientist. Data scientists, these are some of the skills the data scientists. Data management, data scientists need to know how to what? Collect data, store data, clean data, filter data. That is, you need to know how to collect the data and prepare the data. That is one thing. This is what's called data management. You need to know how can I collect the data. You look at the data sets that we use in Nika, most of the data sets are already collected data as a secondary data. But as a data scientist, you need to know what should I collect the primary data on my own? What kind of data do I need for my analysis, for my task, for the task that is in front of me? And then when I collect the data, how should I store that data, whether it is cloud or standalone storage? And then how will I clean the data to make it very clean by removing maybe by replacing the outlier, removing the outliers, replacing the missing values from the rest. So make sure that the data is clean. How will you filter the data? Use the appropriate attributes in the data. How will you integrate different data? Maybe you have different set of data. How will you integrate it from a real reliable data? And another skill is that you need a large-scale parallel data processing. You need to have the skills, that skill. As a data scientist, you need to have the large-scale parallel data pre-processing or processing skills, how the parallel computing works, so that actually if you have a big data, you can know how to split the data, run it in parallel, and then at the end of the day, you have the result. So there are parallel algorithms that are in existence today. So you need to understand how to apply them in the data. And then statistics and machine learning. Yes, you need to understand the basic statistics. This is why at the beginning of this lecture, we take almost 2 weeks discussing the basic statistics, especially the basic ones. Standard measure of dispersion and measure of central tendency. I think we have all discussed that. So these are some basic statistics, but you may need advanced statistics so that you can understand how the concept of the algorithm is working, and then the machine learning algorithm also, because machine learning actually is derived from sometimes it's a section of statistics and mathematics. So you need to understand. That is how to do the data modeling using the machine learning, how to drive inference from the data from the rules generated, how to do a prediction within the model, how to recognize the pattern. So all these the application of machine learning, which I believe we have done some in the lab, and then we have seen how we can make some certain prediction when you do the classification. We understand how to develop the model, how to do some certain predictions, and then how to recognize some certain patterns from the data. So this is important also as a data scientist. We need to understand that concept. And then interface and data visualization, yes. Of course, nowadays, if you want to develop an application, you want to develop a system, you need to understand how to develop the interface. So understanding of human-computer interaction design is very important for a data scientist, because sometimes actually there are rules and regulation governing the human-computer interaction or interface design. So it's not just to say that, okay, now I will sit down, use a particular template and do design. No, you need to understand the basics. You need to understand the regulations
how does the best interface is being developed? And then how can I have the interface which is more attractive? Actually, when I link it with my model, then it can work perfectly and reliably. And then visualization, and then you have to understand how to tell the stories, because as a data scientist, you need to also know how to convince people to understand what you do, especially in decision making. So this three-Conway diagram actually need to have for him to actually become a data scientist. One is a math and statistics knowledge. Yeah, of course, you need to understand the concept of mathematics and then statistics, because actually it is part of the major subset of the data mining or machine learning algorithms. And then substantive expertise, you need also that expertise like the traditional research about how do you do research, and then the knowledge of data science, actually the intersection. You can see data science at the middle, and then the machine learning also intersects with knowledge of statistics and mathematics. And then the hacking skills, when we say hacking skills here, we are not referring to the black hacking. White hacker, becoming a white hacker is important, because sometimes you are working with an organization, you need to know how to prevent that organization from hackers. So understanding the concept of how this hacking is being done is important, because you are dealing with the data. And for one, actually, black hacker attempt to intrude into the database, definitely it can cause problem to you. So understanding what they are doing is important, but not you to do it. So you need to understand how they do it, so that you can prevent yourself or prevent your data. This is why actually as a human being, so we can understand, oh, how this thing is being done, so that I can go away from it. Even in Islam, actually, it is permissible to understand how the particular sin is being done, so that you can prevent yourself from committing that sin. So this is why hacking skills is important, actually, to understand how it is, because as a data scientist, you are head, for example, a particular organization, they expect you to do everything to protect or to prevent their data from intrusion, from hacking, from whatever. So you don't know that you have the knowledge, actually you cannot have. You cannot do anything to prevent that organization. So it is very important. So this three combo actually summarizes some of the skills needed, and then what to do. And then also there are some tools that you need to understand. Maybe you understand some. We only use Weka in the lab, so there are a lot of tools that are needed for, like the programming languages, many programming languages like R programming, Python, C++, C#, and the many more. Even C++ and Java, you have the knowledge of that can help you. And then development tools, data platforms like the SQL, NoSQL server, and the rest. And then the cloud servers, all this can help you if you understand how to work. As a scientist, you need to understand that the data science, virtual machines, machine learning, and AI tools, what tools are needed. So a lot of tools are there. You just need to understand how you can apply them, how you can integrate them into your model. And then data exploration and visualization. And there are a lot of visualization methods are there also. And then data integration tools. So whatever you want to do, actually there are some tools, some are free, some need some subscriptions for you to become a very good data scientist. So I think with this, we come to the end of the lecture for this semester. We hope, inshallah, the little knowledge you get from me can help you and open your mind on how to become data scientist, or how to apply data mining concept in your day-to-day activities on your future life. So you have any question? We still have minutes, I think 15 minutes to the time. Yeah, some references and interesting videos that you can use You can watch some videos actually about the data science for beginners, introduction to machine learning, data science versus big data versus data analytics, data science crash course. So a lot of things. Advisably, actually, once you have some free time, you need to actually be consulting some YouTube channels and then other relevant channels to understand more about the data science. As I said, actually, as I said earlier, regardless of the domain, you need to understand the concept because today we are into that. So you have to go with the current trend of the technology. So as a student, wherever you find yourself, especially as a computer science student, you definitely need to know a lot about how you understand the data because you will be dealing with the data wherever you go. So data is the oil of today, the oil of 21st century. So any question, please?
Sir, I have one question.
Okay, go ahead.
On the skill set of data scientist, I understand the role, the skill set, the skill set of the data scientist, as you mentioned, on the skill.
Okay.
I understand the role about white hacker and the black hacker. But why does it have the danger zone in between hacking skill and substantive expertise?
Maybe your mic has problem.
Oh, sorry. There's a danger zone in between hacking skill.
Oh, okay. The danger zone
Ah,
between
yeah.
this in the let me go back to this. Okay. You mean in the
Slides.
okay, you mean the Drew convoy diagram.
Ah, yes.
Yeah. Because actually, why we say a danger zone is a knowledge of hacking. And sometimes, is a dangerous thing.
Yes.
Okay, so this is why you say it is a danger zone. But actually, you need to understand how you are going to use the knowledge because sometimes, as I said earlier, actually, you need to have the knowledge, but it depends on how you apply the knowledge. Because nobody will say, okay, now I will not learn how to do the hacking, but how to use it is a problem. You get the point?
Yes.
Yeah, so this is why it's coming a danger zone based on the Drew convoy diagrams. Okay, now it is a danger zone because if someone learn it and use it actually unethically, then definitely it is a danger to them. You get the point?
Yes.
Yeah. So this is why they have that.
I see. Okay.
Yeah.
Thank you, Doctor.
Because this is why you see that it is between the substantive expertise and the hacking skills. So in between that, this is where you have that knowledge. Because it is substantive, actually, it is important, but sometimes actually it involves the hacking, then that means it is a problem if you use it in an ethical way.
Okay, I understand.
Okay.
Thank you.
Thank you. Because when you look at the diagram, to understand even the hacking, also you need to understand how the machine learning is working, what the data science is also all about. You get the point? Because it is part of it.
Okay.
Yeah.
I understand now.
Okay. So any other question, please?
No question.
No question?
No question, sir.
Okay, so I think we are going to stop here. Inshallah, prepare yourself. You are going to submit your project on Monday. So I will give you the link where you are going to submit. And inshallah, on Tuesday, for group C and D, we are going to start our presentation. So prepare yourself well. We'll meet in the lab. This week is going to be week 13, so it is our turn to use the lab. So we are going to have it physically, inshallah. So I will share with you within the weekend the link on where to submit the drive by Google Drive to submit the projects. Then make sure you submit before the deadline. So that, because I need to go through the submissions before the date of the presentation, especially for C and D. We are going to have session on Tuesday, sorry. And even that Tuesday is early morning. So this is why I want you to submit Monday, maybe around 12 p.m. so that I will have a bit time to go through some submissions for C and D. Right?
Yeah.
Okay.
Okay.
So thank you. Jampalagi, see you next, inshallah. I hope the knowledge you get on data mining will help you shaping your self and prepare you to learn to become data scientists.
Sir,
Yes.
for the submission, we just need to submit the report, right?
No, not report. No need for the report. There's a slides.
Or also the slides.
The slides, then the other files that we ask you to submit, the model, the data, all the data sets, original data, clean data, process data, reduce data, all this you have to put them in the folder and zip and submit.
Okay.
Okay. Check the template well. Everything is there in the template. The document needed.
Okay. All right. Thank you.
Welcome. Sampai lagi. Terima kasih.
Terima kasih.
Thank you, Dr.
Terima
kasih.
Mashallah. Don't forget to sign attendance, please.
Okay, sir.
Okay, and
Okay,
then when the SUFO is open, make sure you fill out the SUFO, please.
Okay.
Inshallah. Thank you.
Inshallah.
Inshallah.
Sir, I don't think there's an attendance for today on your future.
Oh, there's no attendance for your class? Which group?
B.
B. No attendance in your future?
Yeah.
Oh, subhanallah. It's okay. Let me check it now.
And A as well.
And A as well. Okay, let me check the future right now.
All right. Thank you, sir.
Welcome.